Kia ora koutou. This video is for students doing level 2 algebra. So if you're in my 12 MAS class this year, or 12 MAC, or 11 MCA, this should be good revision of how we can use a really useful pattern called the difference of two squares to factorise. The reason that I'm making this video is that lots of level 2 students who are overall doing quite well with algebra don't spot difference of two squares situations in harder contexts. So I'm going to start with the really basic case in here and then work up to some harder ones. So the first of these, this one here, is very much year 10 or year 11, it's level 1. But often at level 2, you'll find more complicated ones cropping up in longer problems. For example, ones like this or ones like this, where we have to do a few things first before we can see the difference of two squares. Okay, so really quickly going over this pattern, if I've got x squared minus 49, what I'm noticing when I see that and I'm asked to factorise is that I don't have an x term in the middle. Okay, so I've really got x squared plus 0x minus 49. And that makes me go on and have a look to see if this first term here is a perfect square and if this one is a perfect square, and if we've got a difference between the two of them. And if that's the case, then what I can say is that instead of x squared minus 49, we can write that as x plus 7 times x minus 7. So this works out because you can see when I expand it back, I get x squared here plus 7x minus 7x minus 49. Now the reason this is so useful is that if I'd said solve this equation, then if we can factorise it, it's very easy to solve it. And so we get this, and then either x is equal to 7 or negative 7, right? Negative 7 coming from this factor and 7 coming from this one. In this video, just to keep it a little bit faster, I haven't solved equations, I've just done factorising equations. Okay, but hopefully the step from factorising to solve should be okay. I'll cover that off in a different video. So if we look at this next one, we've got 4x squared minus 81. The 81 is obviously a perfect square, 9 nines. The 4x squared we have to look at more carefully. 4x squared is also a perfect square because it is 2x times 2x. The next one, we have to do one more thing first, because if we look at this next one, we see 8 and we see 18. Now 8 is not a perfect square. 2 squared is 4, 3 squared is 9. But if we check out the 8 and the 18, we've got a common factor in the numbers. So I'm going to do the next two examples, and then I'm going to ask you to try a few more flowing on from there, and then I'll go through all of them. So 4x squared minus 81 is equal to 2x times 2x here, plus 9 minus 9. When you've done a difference of two squares, always check it back by quickly expanding. So here we get 4x squared plus 18 minus 18 plus 18x minus 18x minus 81. So that works. In the next one, we add in an additional step. We first check to see if we have any common factors in the coefficients. And here we do. We have 2 times 4x squared minus 2 times 9. And now it's very easy to spot that this is a difference of two squares. So 2 times 2x plus 3 times 2x minus 3. Okay, I'd like you to pause the video now and just try and work through all of these ones. The only thing that gets a little bit harder is that sometimes we have to check for common factors in the variable as well as in the number. So pause the video, have a go, and then I'll go through them. And if you want to, just put me on to double speed. Okay, 8x squared y minus 18y is a close relative of the question before. We've got a common factor in the numbers of 2, and then we've got a common factor of y. So we'll take out the 2y as a common factor, and we're left with 4x squared minus 9, which equals 2y times 2x plus 3 2x minus 3. Next one, easy, w squared minus z squared. This is a perfect square, and this is a perfect square. So now we're working with two different variables, w plus z, w minus z. Next up, we have to be a little bit careful here to think about how is this a perfect square. It's tempting to write the square root of 8 here, but that's not going to be right, because when we have the same base, we add the powers. So w to the power of 8 can be broken into w to the power of 4 times w to the power of 4. Z to the power of 10 can be broken into z to the power of 5 times z to the power of 5. And now it should be obvious that I've got a difference of two squares. So I'm going to have w to the power of 4 here and here, plus z to the power of 5 minus z to the power of 5. And when we expand that to check it back, we see that we get w to the power of 8 here, and we get plus this middle term, and then we get minus the same middle term. When we do this, minus z to the power of 10. Okay, next one. Now the next four are just variations on the things we've noticed so far. So x minus 16x to the power of 5 has a common factor in the x's. So we'll take out x. X times 1 gives me x minus 16x to the power of 4. This is a perfect square. This is 1 squared. So I've got x times 1 plus 4x squared times 1 minus 4x squared. That's that one done. Right, next up, 32p squared minus 18q squared. First, check out the numbers. Have I got a common factor? Yes, I have. 2. Right, so 2 times 16p squared minus 9q squared gives me 2 times 4p something something, 4p something something, so that's that term. Difference of two squares, so we're going to have a plus here and a minus here, and this will have 3q times 3q. 2 left. Okay, 1 minus x squared times y to the power of 4. Well, we just need to watch out with the second term in here, this one. So if we've got x squared times y to the power of 4, that's equal to x times y squared times x times y squared. So that's how we can break out the perfect square. 1 minus x squared y to the power of 4 will equal 1 plus xy squared times 1 minus xy squared. And the last one I put in just to make you think about how adding powers works. So it's a little bit trickier. We've got a common factor in my numbers of 2. So we've got 2 times 9x to the power of 2y minus, sorry, not 9, 2 times 4x to the 2y minus 9. This is an easy perfect square. And in this one here, this is an easy 2. What about the x to the power of 2y? Well, x to the power of 2y is equal to x to the power of y times x to the power of y. And that means that this whole thing is equal to 2 times 2x to the power of y plus 3 times 2x to the power of y minus 3. Okay, that's all for now. I'll do some other videos later on. If you are watching this and you're in my level 2 class this year, if you could flick me an email and let me know, that would be great, or leave me a comment, because I'm trying to decide which videos I prioritise over the holidays. Thanks very much. And if you have any questions, just leave me a comment and I'll try and answer it.